Hello everyone, I'm Jake. Today I will introduce my Hunyuan 3D image-to-mesh workflow. The big news suddenly came that ComfyUI supports Hunyuan 3D natively when I was recording this video. Although it is only a mesh voxel preview and cannot be used for other purposes, it marks the arrival of the ComfyUI three-dimensional era. Hunyuan 3D is the best open-source model currently on the market, and the results can even match the product level. This workflow is quite complex, so I split it into multiple sub-processes. Part 0 is image preprocessing. The first part is mesh reconstruction. The second part is mesh optimization. The third part is multiview texture generation, which includes 3 methods. The fourth part is the refinement of multiview textures. The fifth part is the final map baking, including automatic UV unwrapping. Press the key to get to the process and project settings. Please note that there are 2 mesh reconstruction ways, CRM and Hunyuan 3D. Hunyuan 3D's model optimization, texture baking, and other subprocesses can support meshes from any source. I integrated CRM into the Hunyuan 3D workflow because I think the 2 workflows are very similar, and Hunyuan 3D is an all-around upgraded version of CRM. Although CRM is not accurate enough, the mesh it generates is the closest to the reference image, which can make up for the shortcomings of Hunyuan 3D. If you are interested, you can check out my previous video introducing the CRM. Let's take a look at the comparison of the meshes. The 3 mesh reconstruction methods used the same reference image, and the multiple views were obtained by high-resolution upscale of the CRM results. That is to say, CRM and the multiview modes of Hunyuan 3D use the same set of multiviews. As seen from the front view, the proportions and structure of the mesh generated by the CRM are closest to the reference image because it is solved based on the orthogonal perspective. If you change the camera to perspective mode, the front view of the model generated by Hunyuan 3D will be closer to the reference image. I speculate that Hunyuan 3D performs distortion correction on the reference image. It is a pity that the details of the model generated by CRM are not as good as those of Hunyuan 3D. The former has only 30,000 to 40,000 faces, while the latter has millions of faces. The multiview mode Hunyuan 3D generates a mesh based on multiview reference images, similar to CRM, and is more accurate than the single image mode. How to choose? If I want to be very close to the reference image, I would choose CRM. If I want a high-quality mesh, I would choose Hunyuan 3D. Regarding the distortion correction problem of Hunyuan 3D, I tried to reduce it using camera correction in Photoshop. I generated 2 images, one with increased and one with decreased perspective distortion. I had planned to add a distortion correction subprocess to my workflow and found a custom node for fisheye correction. It has rich parameter controls, and the correction results are very close to Photoshop. After comparing the meshes generated by different distortion-corrected images, I found that the problem is more complicated than I imagined. The issue of inaccurate mesh proportions and structure is not just caused by camera distortion correction. So I gave up further research and just added CRM to my workflow. I give up the Hunyuan 3D node in 3D Pack because it encapsulates all the functions and is not good for either memory management or process control. If you have already installed ComfyUI 3D Pack successfully, installing Hunyuan 3D Wrapper will be easy. You can choose to install it using Git or ComfyUI Manager. You need to update diffusers to 0.31.0 or above, which will not affect the use of the 3D Pack. You can choose to update automatically or manually. I put the command in the instructions. What is more troublesome is the need to recreate the local custom rasterizer. When I installed it, I chose the method provided in the 3D Pack, but did not in the Hunyuan 3D Wrapper. First, enter the custom rasterizer directory in the official repository of Tencent Hunyuan 3D and copy the path. Then use Git to download the contents in this directory. After unzipping, go to the corresponding directory, enter the command in the CMD to create the installation file, and install it. You should create and install it using ComfyUI Embedded Python with 3D Pack and the Hunyuan 3D wrapper installed. I put the commands in the instructions. I would also like to recommend a custom node called ComfyUI MTB. We will use several of these nodes in our workflow. The first is the color selection, which is used to specify the background color of the reference image. The second node can transform the image. Rotating it 180 degrees can make the CRM bottom view consistent with Hunyuan 3D. The most important one is Deep Bump to generate PBR textures. This includes normals, curvature, height, ambient occlusion, and roughness maps derived from the height. Of course, this solution is not as good as advanced 3D texture tools such as Substance or Materialize, and is only used as an alternative. The embedded Python environment of ComfyUI with 3D Pack installed can already meet the MTB node's needs. We changed some settings to prevent other environment dependencies from affecting the 3D Pack. Find the endpoint.py file in the MTB directory. Turn line 27 into a comment to solve the error at startup. In addition, we do not need to install some environments in the requirements file. To be safe, I rename or delete this requirements file. If the MTB is updated, you need to repeat these two steps. You also need to prepare this high-quality image save custom node. It can save and load 32-bit color depth files. Because 32-bit color depth has a wider color range and more delicate color transitions, it can improve the generated results for mesh reconstruction and texture generation. Two settings need to be added to the startup batch file. The first line adds the environment variable to enable OpenEXR for OpenCV. The second one adds a 32-bit V variable to ComfyUI startup. In addition, because my video memory is only 8 GB, I added low VRAM variables just in case to run Hunyuan 3D. I'll include these two lines in the instruction. Now let's look at the color information a high color depth EXR image can contain. Both images are 32-bit EXR images. The one on the right is a high dynamic range panorama map, and the one on the left is an image generated by ComfyUI and saved as an EXR file. We adjust the exposure to see the color information contained in the file. The image on the right records high dynamic range color information with values exceeding 1. So when the exposure is reduced, you can see the details in the overexposed areas. You can still see the details even when the exposure value is very low. This is the power of high dynamic range and high color depth files. The image on the left is 32-bit color depth, which has richer color information than 8-bit, but does not include a high dynamic range, which can be seen by changing the exposure value. This is probably because the image generation model is trained based on low dynamic range images. High dynamic range information is still missing even though ComfyUI enables 32-bit V for encoding and decoding. Let's load this high dynamic range panorama image into ComfyUI and adjust its exposure. You can see that ComfyUI or Load EXR node or exposure node blocks the high dynamic range information. This means it only handles colors with values between 0 and 1, which I accidentally discovered is an area where ComfyUI could be improved. Therefore, its use is still limited even though the EXR file can preserve all color information to the greatest extent. We can also make a logical inference. If we skip the EXR saving and loading process and use the image generated by ComfyUI to proceed to the next step, such as the img2mesh, the result will be native. This intermediate saving and loading process will not produce a better result than the native one, but is useful for subsequent image processing work other than ComfyUI. Let's first take a look at the process settings. 00 is image preprocessing, and 01 is mesh reconstruction. 02 is model optimization. 03 is multiview texture generation. 04 is multiview texture refinement. 05 is final texture baking. The load panel corresponds to the loading function of the subprocess. Because the img2mesh consumes a lot of RAM and VRAM, so after each step is completed, disable the current step and enable loading. For example, after we complete the delighting subprocess, we need to close the generation process and enable the loading process. The following section is the project settings. The first thing to choose is whether the workflow uses CRM or Hunyuan3D for mesh reconstruction. This will affect a series of input and output parameters. For example, the orthoscale ratio parameter in Hunyuan3D. It means that the reference image size is equivalent to a multiple of the subject outline and controls the gap to the edge. Because the CRM resolution is only 256, a higher orthoscale ratio is required to avoid mesh reconstruction failure caused by the subject being too close to the edge. The default value 1.2 of Hunyuan3D works for both methods. I changed it to 1.1 to improve the utilization rate of the reference image pixels. Next is the project name, version number, and reference image resolution. There are also model settings for Upscale and ControlNet. ControlNet is used during Multiview texture generation and refinement. Let's take a look at the first part of image preprocessing. We can choose to load a single image or multiple images. There are two more steps to take. The first is to remove the background, and the second is to adjust the scale ratio of the subject to the image. This image already has an alpha channel. You can turn off the background removal group. After processing, the subject is closer to the edge of the image. When we switch to CRM mode, the scale ratio of the subject will shrink. Let's change to another image. This image is Johnny9, provided by Billy Battis from Discord. Enable the background removal and take a look. If you want to load multiple views, copy the storage path. Enable Multiview loading and enter the path. We need to calculate which image to start from and how many images to load. Note that the index starts counting from 0. All 6 images have been loaded and pre-processed. You can also choose to load one or multiple EXR files. The second part of image preprocessing is delighting. Enable the group and run. Let's look at the result produced by the default settings. The highlights and shadows are indeed removed, but whether it is useful or not is a matter of opinion. This step can be done with a 2D application like Photoshop or even ComfyUI. I will compare it later. I provide 3 ways to set the background color of the reference image. The default is to use a grayscale value of 1.0. According to the description of Kajai, the author of the Hunyuan3D wrapper, the brightness of the background color will greatly affect the result. Under normal circumstances, maintain the default value. Since this will impact the result, I left this parameter. The first is the value of the solid mask. The second is the hex color for empty image, which requires referring to the formula to input the RGB value. And the third is the color selection node of MTB. The paths and names for saving files in the workflow are preset. There will be a subdirectory named after the project in the output directory of ComfyUI. There are 2 subdirectories, CRM and HY3D. The files will be saved in the directory corresponding to the mesh reconstruction method. Files are categorized by type. The results of the delighting process just completed are saved in PNG and EXR formats respectively. Copy the path and go back to ComfyUI. Disable the delighting generation group and enable the corresponding loading group. Please note that you need to refresh the fast bypasser node of RG3 after enabling the group to synchronize the node status. Paste in the path to load Delight Multiview. If you want to read the second set of 6 images, adjust the starting index to 6. The last 2 image pre-processing steps are adjusting the image size and background color. In CRM mode, the image size follows the reference image resolution parameter. Kajai recommends the size of the Hunyuan3D reference image to 518, but I found that it is not limited. The default is 1024, but it is allowed to be customized. The default background color is black, but you can change it to white. The results will be slightly different. For single image generation mode, the current image is loaded by default. When loading multiple views, pay attention to the index number of the front view in the sequence. The Hunyuan3D front view is the first image, with the index number 0. The CRM front view is the last image, with the index number 5. I used ComfyUI to replicate the two common ways of delighting a texture. This workflow requires two custom nodes, was and layer style. Since additional environments need to be installed, this workflow is executed in a separate ComfyUI. Let's first talk about the simple way. Blur the original image, divide it by the average color of the original image, and then multiply it by the original image. The divided blend creates a mask with white in the dark areas and gray to black in the bright areas. Multiplication blending preserves the dark areas and darkens the bright areas. Another method is more complicated. First, use two high-pass filters to get the bright and dark contour colors, and then blend the two using soft light. The high-pass filter has the same function as Photoshop, in which you can control the contour range by radius. The second step is to blend the average color of the original image with the contour color using vivid light. The third step is to use the color blending mode to restore the original image color. Finally, the dark details of the original image are added by extracting the dark mask. These two methods are implemented using approximate methods that lose color information. It's useful when making tiled textures, but it's unsuitable here. In comparison, the results of Hunyuan3D's delighting model are amazing. It not only extracts the diffuse color and removes the highlight shadows, but also manages to restore the original color in the bright and dark contours. Color information is not lost, but rather gained. Let's try a different image. Here I added an extra step to add a gray background. Compare it with the result generated by Hunyuan3D. The result of the simple method is bad. The result of the complex method feels a bit better and might be even better if we adjust the parameters. However, the bright contours are difficult to eliminate because the contrast is too strong. Overall, Hunyuan3D is good for delighting and can be used with some color correction. Mesh reconstruction solutions like CRM, Hunyuan3D, img2mesh, and Unique3D include multi-view generation methods. There is also this MV adapter custom node, and the latest version allows mesh reference to generate more accurate multi-views. But this is a pre-process of the image to mesh. It is not included in my workflow. Note that the MV adapter can be used normally in ComfyUI, where 3D Pack or Hunyuan3D is installed. It is recommended to delete its requirement files to ensure that it does not affect the existing environment. Press the number 1 key to the Mesh Reconstruction section. There are 3 methods. The above 3 are steps of CRM, Multiview generation, Position coordinate generation, and Mesh reconstruction. The following 2 are the single image and multi-image modes of Hunyuan3D. Enable single image mode and run. The generation is complete. I chose the standard model, but you can also choose the fast, turbo, or the newly launched mini version. I lowered the guidance scale, so the mesh has more faces. The generated result has 2.3 million faces and 580,000 vertices. Lowering the guidance scale will cause unnecessary bumps on the mesh's surface. Close the model reconstruction group and proceed to the next step, model optimization. Next, we use Multiview to generate a mesh. Note that the Multiview reconstruction model is different from the single image. When I first started testing, I used the single image reconstruction model to handle multiple views, and it actually worked, but the result was a patchwork mesh. You can try it if you are interested. Please note that you need to indicate whether the multi-view sequence loaded is Hunyuan3D or CRM. If it is a CRM multi-view sequence, it should be set to true so that the corresponding view in the sequence can be automatically loaded correctly. Let's give it a try. I changed to a set of Hunyuan3D sequences, obtained by upscaling, refining, and changing the order of CRM Multiviews. I originally thought about using CRM Multiview to control the proportion and structure of the mesh generated by Hunyuan3D. It seems that Hunyuan3D also performs distortion correction on Multiview, so there are still some differences from the reference image. Find the mesh just generated. The suffix is 01 Reconstruction. Press Shift and right-click the mouse to read the file address. You should remove the quotation marks at both ends when entering the path address. Hunyuan3D Wrapper provides 4 optimization methods. The first one is called Post-Process Mesh. The second one is called Instant Mesh RemBG. There are also Fast Simplify Mesh and BPT. When enabling the group, refresh the status of the corresponding nodes in the bypass panel by turning them all off first. It is recommended to use Post-Process Mesh or Instant Mesh RemBG. Post-Process Mesh can delete floating faces not connected to the main body. Let's take a look at the instructions during runtime. Different mesh optimization methods require corresponding environment dependencies. This BPT is too complicated, so I haven't installed it. The optimized mesh has 24,000 vertices and 50,000 faces. Close the group and prepare to move on to the next process. Follow the same method to find the optimized mesh with the 02 optimized suffix. Copy the file address. This camera setting is important. Try not to touch the parameters. If you are familiar with 3D Pack, you will know that it controls the position of 6 cameras with azimuth and elevation angle. It uses orthographic cameras. The camera order is front, left, back, right, top, and bottom. The camera weight is a bit like the priority setting in Texture Projector, which controls the hierarchical relationship when projecting textures. The higher the value, the higher the layer it goes. The weight order is front, back, left, and right, top and bottom. The next step is to generate a series of 3D property maps based on the mesh. This is the same process as my other Get 3D data workflow, but more accurate. Note that the normals generated in this step are in world space coordinates, the format required by Hunyuan3D Multiview sampling. Turn off the generation group and enable the loading group. This time we load the EXR format. The normal maps are in the normal_W folder and the position maps are in the position folder. There are 3 groups of pictures in the folder. We load the third group, starting with index number 12. The next step is Multiview sampling. Before that, we store all other 3D information, including depth, Lineart, and tangent normal map, all of which will be used in subsequent processes. All are loaded in EXR format. They are assembled into one image in 3x2 and located in the folders depth_grid, Lineart_grid, and normal_grid. There are 3 ways to generate multiview textures. The first is achieved by upscaling and refining the CRM multiviews. The second uses depth, Lineart, normal maps, and text-to-image to generate variable textures. The third is the multiview sampling provided by Hunyuan3D. We will use this first. There are 2 selection parameters to note. whether to use multi-view referencing, and whether the multi-views are CRM or Hunyuan 3D sequences. A multi-view reference would certainly be more accurate. The generated results do refer to 4 multi-views. What if we don't use multiple views, but only refer to the front view? The results will be a bit wild if only a single reference image. After completion, close the generation group. Next, we use text-to-image with control nets to generate more variable multi-view textures. Disable unnecessary groups. Enable the depth, Lineart, normal map loading group, as well as the text-to-image generation group. If in multi-view mode, enter the correct front view index number. We first generate a large image of 1536 by 1024, a 3 by 2 combination of 512 for each view. Disable the Upscale module when testing. By default, I only connected 2 control nets, depth and Lineart. Connect it to the controlnet_2 slot if you use a normal control net. The background color of the IP adapter reference image greatly impacts the result. By default, I chose white. This looks fine. Increase the resolution to 2304 x 1536 or 3072 x 2048. That is 768 or 1024 resolution per view angle. My computer performance is relatively poor, and it took 18 minutes to generate it. The image quality is very high. These dense holes are details caused by injecting too much noise, which can be reduced during the next generations. Next, I will introduce how to generate CRM multi-view textures, an important part of the CRM Hunyuan3D process. We first generate CRM multiple views and reconstruct the mesh. Remember to switch to CRM reconstruction mode.
On a bright sunny day, the birds start to sing. As the gentle breeze blows, it dances on my skin. I feel the warmth of the sun filling up the air. It's like a symphony of nature everywhere. The sound of the waves crashing along the shore, the rustle of leaves as they fall to the floor, the rhythm of raindrops hitting the ground. It's a harmony of nature's music all around. The true harmony of nature's music all around.
There is a pre-processing before the generation. I adjusted the sequence from CRM to Hunyuan3D. At the same time, rotate the bottom view 180 degrees to match Hunyuan3D. If you increase the resolution to 1024, Tile Control Net can be enabled, but the generated image will appear blurry and lack detail. The original sequence has been adjusted and the generation is finished. Each image was upscaled from 256 to 768. The bottom view is rotated 180 degrees and placed at the end. After refinement, it becomes 3072 x 2048 with a resolution of 1024 per view. We have generated multi-view textures in 3 ways, which will be further refined and upscaled to 2048 resolution. The Hunyuan 3D mode has 2 types of multi-view textures, sample, and text-to-image. For CRM mode, there is also a Multiview upscaled version in addition to these two types. I selected the text-to-image Multiview texture of Hunyuan3D for the next step. Only one of the images was loaded. The depth and Lineart control nets are enabled for the secondary refinement. Normal control net is not used by default. Continue injecting noise to increase details during refinement. Note that the 3D info maps and the Multiview textures must belong to the same mesh. You can skip the second refinement if you think the details are enough. Next, use the Ultimate Upscale node to upscale the textures to 2048 resolution. In the previous process, we split the texture into 6 pieces. Here you need to select which texture to use as the front view. In Hunyuan3D mode, the generated front view is always used, whether sampled, text-to-image generated, or refined. Because the mesh and the front view are consistent in CRM mode, there are 2 more ways, the delighted or the original reference image. I recommend CRM because its mesh and texture can be very close to the reference image. The current demonstration is the Hunyuan3D process, so we do not need to touch this parameter. Load the refined texture and run. Okay, the Multiview textures with 2048 resolution are generated. Further refinement may still need to be done in a 2D application like Photoshop. After all, tinkering with ComfyUI is still very troublesome. Next, there is an optional process of generating PBR textures, which uses the deep bump and color correction nodes in MTB. Find the upscaled textures in the color subdirectory of the MV texture directory. Should this step be done before or after the texture baking step? If you manually unwrap the UVs for the mesh, you can consider doing it after baking. When you use Deep Bump for the first time, you can enable this button to download the model file automatically. The normal map produced by Deep Bump is in Unity format, with the RG coordinate 0, 0 located at the lower left corner of the image. Because the normal map is based on the texture tangent space, projecting requires complex space coordinate transformation. However, this is currently difficult to achieve in ComfyUI, so Multiview normal maps are only used as a process product for generating other PBR maps. If you want to generate the final normal map, you should process the baked color map, but the result is not ideal when the UV is automatically unwrapped. The curvature or edge map is derived from the normal map. The height map is also derived from the normal map. The ambient occlusion and roughness maps are mutated from the height map. The last 2 maps can be fine-tuned using the color correction node. This step generates a lot of images, which will cause ComfyUI to freeze. Pressing these 2 free cache buttons is useless, and you need to refresh the web UI. You can use substance or materials to generate better PBR textures. Finally, we come to the last step, texture projection and baking. The top group is for the color map. The bottom group is for other PBR maps. Although I have listed the normal map projection and baking process, completing it here is not recommended. The mesh loaded here can be a previously optimized one, or the one optimized and UV unwrapped in a 3D application. Hunyuan3D provides a node for automatically unwrapping UVs. It is enabled by default. However, please note that every time you re-execute this node, the UVs will be re-unwrapped. Therefore, either all the projection and baking must be completed in one go, or the mesh loaded has UVs with automatic UV unwrapping turned off. Load the color maps and mesh, then start running. This process is a three-step operation. The first step is texture projection, projecting the 6 view textures onto the model according to the 6 view angles and arranging the texture layers according to the camera weights. The second step is vertex in paint texture. I guess this is used for vertex color baking. The role of this node here is unknown and can even be bypassed. Texture baking also generates a mask of the texture range. The third step is to perform texture seam removal, the familiar texture dilation, called in-paint texture in Hunyuan3D. Let's take a look at the finished mesh. I also recommend another solution for texture projecting and baking, my UE toolset, Texture Projector and Property Baker. In addition to completing the existing work of Hunyuan3D, this toolset also supports multi-quadrant UV of mesh, also known as UDM, supports more flexible projection layers and mask control, and will soon support the projection of normal maps.
Whispers in the night, stars that lose their light, silent winds they blow, nowhere left to go, drifting further out, filled with waves of doubt, echoes of your name. Everything feels the same, lost in the clouds, no way to come down. In the sea of dreams, nothing's what it seems. Floating in the mist, days that don't